Good afternoon. I'm Spot On Weather meteorologist Matthew Euler, and today, as promised, we are going to get into the 2018-19 winter forecast. All right, this is an image on the title of the presentation showing you pretty good snowfall from the past in the Virginia Beach, Norfolk area. And the last two winters I'll have to say, I've been very impressed by the level of storms that we have had in the wintertime. Two major winter storms the last two Januaries. January 2017 and then January 2018, another big snowstorm. So, we have to ask ourselves, maybe this weather pattern is changing. Maybe our norm is getting more snow now in Southeast Virginia for some reason, or maybe it's just a temporary shift in the pattern. But anyway, let's get right down to the forecast. I know you're just dying to hear this. 2018-2019 winter forecast, so let's get right to the forecast considerations right off the bat. All right, so for this winter in particular, we're going to talk about the emergence of El Nino and the weather conditions associated with typical El Nino winters. I'm going to show you that here on the next slide. We also need to consider the activity of the hurricane season, whether we have extremely high or low ACE values. ACE standing for accumulated cyclone energy, and the potential energy deficit / surplus across northern hemispheres. So does that lead to less or more baroclinicity in mid-latitudes? Okay, and it's interesting now, I'm recording this, and Hurricane Florence has gone into, right around the Wilmington, North Carolina area, and has sat up over the North Atlantic Ocean basin with quite a pack, quite a punch of power, very high wind speeds. That no doubt has increased the ACE value across the North Atlantic for hurricane season this year. Also, we need to talk about the October Siberian snow cover, the depth and extent, and that is done by Dr. Judah Cohen of AER, Atmospheric Environmental Research. And that's a really cool thing to check out, especially throughout the course of the winter. Teleconnection indicators, we need to talk about the North Atlantic Oscillation again, the Arctic Oscillation, the AO. PNA stands for Pacific North American Pattern, and the MJO, the Madden-Julian oscillations in the Pacific. And then also, we need to mention sudden stratospheric warming events, their frequency and duration. I've got something to show you on that. And then also, we take into account sea surface temperature anomalies in developing the winter forecast. And where's the location of those warmer, anomalously warm areas or anomalously cold areas in the ocean? Okay. That has a lot to do with long wave patterns at the jet stream level and determining what kind of locked in patterns we may see for extended periods of time, where those warmer or colder than normal sea surface temperatures reside. All right, so the first thing I want to start off with, really, when we talk about forecast considerations, is the El Nino winter pattern. This chart shows you a typical diagram of what to expect during typical El Nino winters. Now, I'm using that word typical very strongly, emphasizing it for a reason. The reason is because no two El Nino winters are ever exactly alike. We can look at seasonal forecasting and say, hey, it's going to be an El Nino. This is what should happen. But it's not always the case. Sometimes you have some of the other teleconnection patterns that are more dominant than the El Nino itself, such as the North Atlantic Oscillation or the AO, the Arctic Oscillation. Or maybe the Madden-Julian oscillation phases aren't lining up. They're not matching up with the El Nino typical weather pattern. So I use that term very loosely, typical, because not all El Nino winters are ever alike, just like no two human people are ever alike exactly. All right, so notice the typical El Nino weather. This is it for the U.S. We typically have a warmer stretch of air from Alaska into western Canada, down into Minnesota, Wisconsin, kind of the northern plains states, the Dakotas. A drier weather pattern generally associated with into Illinois, Indiana, and Ohio. And then you get a cooler, more active subtropical jet stream on the Gulf Coast states, basically from Southern California through the Gulf Coast states. Because of the increase in cloud coverage, you generally have cooler, below normal temperature patterns setting up on the deep south. Okay. So that's generally what happens. You get this nice ridge to develop over the Pacific Northwest, upper air pattern, the jet stream. We got a ridge pattern in the western Canada and Alaska. and then you get a little bit of a more active subtropical jet, which gives you cooler and wetter than normal winters. This is the current situation. Earlier, what we were looking at is the anomalies of the water temperatures. For El Nino, what we're looking for is warmer than normal sea surface temperatures off the coast of South America, in the eastern and in the eastern equatorial central Pacific. All right. Now, we do definitely have anomalies going on at the present time in the sea surface temperatures, and this is evidenced by the fact, too, during El Nino years, you typically get more hurricane activity around Hawaii, which we've already had a couple big-time threats to the Hawaiian Islands within the tropical areas, in the tropic season overall, with hurricanes. The classifications are on the bottom of this slide as well. If you see that weak El Ninos are classified as a 0.5 to 0.9 degrees Celsius sea surface temperature anomaly. Strong El Ninos are 1.5 to 1.9 degrees Celsius sea surface temperature anomaly. And we look at the El Nino region 3.4. That's the area we really hone in on, that particular area, which is the eastern equatorial Pacific. All right, and it's defined there next to, when I have the Niño 3.4 region, you see 5 north, 5 degrees south latitude, and it's bounded by longitude lines 120 west to 170 degrees west longitude. Now, these are the model forecasts from the Climate Prediction Center, which is a branch of NOAA that shows what the models are indicating for El Nino, to the development of El Nino as we move on into the fall and this winter. All right, so all these colored lines represent different forecast or climate models. The dark line in the center there is 0.0. That is your normal sea surface temperatures across the eastern and central equatorial Pacific, okay? So all the models are indicating are above that 0 degree line, showing you anywhere from a 0.5 to a 1.0 degrees Celsius warmer than normal sea surface temperature anomaly in that Niño 3.4 region, okay? Most models cluster near 1 degree Celsius sea surface temperature anomaly, and generally it's on that line between weak, higher weak El Nino, upper end of the weak El Nino range, and the lower end of the moderate range of El Nino. An El Nino watch has been issued by NOAA Climate Prediction Center, and there's a 70% chance of El Nino developing this winter, the time frame November through February. Now, as I mentioned before though, word of caution, no two El Nino winters are exactly alike. Now, I'll give you my own personal experience. When I was out in San Diego for a few years, all we heard about was, oh, El Nino's coming back. That must mean that the drought is going to end in Southern California. Guess what happened that winter when it was supposed to be a lot of rain because of El Nino? Absolutely nothing happened. Nothing changed. So again, just because it's an El Nino winter doesn't necessarily mean it's going to pan out and behave like it should. And that's the real trick and challenge of the atmosphere. It generally has a mind of its own sometimes and throws curveballs at us in the meteorology business. Now, the magnitude and duration of above normal sea surface temperatures in the Niño 3.4 region are significant for U.S. weather. Research has proven this. During El Nino winters, whether we talk about El Ninos or La Niñas even, it has been proven that the sea surface temperatures in that particular area, the Eastern Pacific, have a significant role on our winter weather in the U.S., okay? And generally the reason is because it alters the long wave trough ridge configuration on a global scale. And when I tell you about long wave trough and ridges, I want you to think about the jet stream position overall. Keep in mind that other teleconnections, again, I cannot emphasize this enough, the North Atlantic Oscillation, the Arctic Oscillation, the Madden-Julian Oscillation, these can all be stronger and more dominant than El Nino, actually counteracting El Nino's effects or strengthening its effects, all right? Similar to a constructive versus destructive interference phase of waves in general. And we are dealing with longer atmospheric waves, the jet stream configuration, okay? All right, so this is past El Nino years, and they're shaded in red. And this goes back just to 2006, all right? I put some key notable El Niños in the past 12 years at the bottom there in the font, in the text. But generally, some of our notable El Niños in the past 12 years: 2009-2010 winter season, the 2014-15 winter season, the 2015-16 winter season. The 2014-15 El Nino winter was forecast to end the California drought with a more active southern storm track and wetter weather. But guess what? I already explained this. I was down in San Diego at the time, and El Nino was coming that winter, 2014-15. It was supposed to be a major drought buster. Southern Californians were worried about flooding. You know, they got a lot of hills out there. And guess what happened? It continued to remain dry, and the drought continued. So I want to re-emphasize that point, that no two El Nino winters are ever exactly alike. Hurricane season activity. All right. Here is my premise on this. Energy transfers from lower latitudes to higher latitudes, okay, from the hotter equator towards the colder poles. Storms are simply mechanisms that nature creates for reestablishing balance in the atmosphere. So, if I have an excess of potential energy in one location, the atmosphere is going to tap into that and develop storms to counterbalance that excess potential energy, okay? So during above and below normal hurricane seasons, we're looking at either more or less potential energy is used in reestablishing this critical global heat balance. Simply put, more hurricanes could result in less potential energy in atmosphere and a lower number of mid-latitude baroclinic cyclones in the winter. Okay? The opposite effect occurs with less hurricanes. The very quiet hurricane seasons, perhaps you get more nor'easter type storms that come up the east coast for southeast Virginia, more baroclinic cyclones. Okay? So bottom line is energy can be neither created nor destroyed in the atmosphere. All right? It's just simply changed from one form to another, and the laws of thermodynamics state that. Okay? That energy can be neither created nor destroyed, but are just distributed somewhere else. So the premise, I take this into account, the hurricane season activity in the winter forecast, because if you have a very lower, I use ACE values in the forecast, the accumulated cyclone energy values. Those are very important to me during hurricane season. If we have a lower ACE season, that means we have less energy that was used, so there's more potential energy perhaps in the following winter season for nor'easter storms that move up the coast. All right. Siberian snow cover. Really, you need to Google this. Check out the Atmospheric and Environmental Research site. Dr. Judah Cohen is awesome. He really put a lot of research and time and effort into showing that increased snow cover over Siberia in October leads to severe winter weather across the mid-latitude continents. And this has to do, again, with the setup of the long wave pattern. You need to look at Asia. You need to look at the Western Pacific. You need to see what's happening with typhoons. Everything has a domino or trickling effect in the upper air and the upper atmosphere. So where these long wave troughs set up and where the long wave ridges set up, that's going to determine whether you have a colder, wetter winter or a drier, warmer winter. Where does the ridges, upper air ridges and troughs set up? For how long do they set up? For what parts of the country do they set up? Okay. Generally, Dr. Cohen showed, though, with his research, that an early increase in snow cover results in much colder air masses forming over Siberia, which eventually propagates towards the U.S. on cold northwesterly jet stream winds. So you get deeper troughs directed towards the eastern United States in this case. You get long wave blocking patterns that will result in these extensive cold air episodes and cold air pouring over the eastern United States from higher latitudes, while ridging occurs over the western United States as a whole. So if there's more snow cover earlier in the season, the colder air masses build up much greater because you have higher albedo or reflectivity off the snowpack. The air mass gets colder and colder and colder. You're losing daylight on top of that. Days are getting shorter as you go into October and November as well. And so that colder air mass is allowed to build up in Siberia. Eventually it's going to ride the winds of the jet stream into the long wave trough into the eastern United States. So basically an updated winter weather forecast will factor in the Siberian snow cover later this fall. Right now, obviously I can't use this because we're not in October yet, but it's definitely something I look at a little bit later on down the line to see if I need to make any revisions to this initial winter forecast. Teleconnections, I harp on this a lot during the winter. If you've seen some of my videos, the teleconnections, AO is the Arctic Oscillation, the NAO North Atlantic Oscillation, PNA Pacific North American pattern. These all just play significant roles in the weather we have. And I haven't even gotten to the Madden-Julian oscillation phases. That's another huge one in the Pacific. What happens in the Pacific really has a huge impact on our weather, our winter weather here in the eastern U.S. and southeast Virginia, mid-Atlantic area, because everything generally migrates or blows from west towards east on those jet stream winds. So anything upstream or to the west of us is definitely going to have a significant impact on this winter forecast. So generally, break this down, simply put, if you have negative Arctic oscillation phases, you generally have colder than normal temperatures across the eastern United States. If the AO is positive, you have warmer than normal temperatures across the eastern United States. For NAO, a negative NAO generally correlates to a larger blocking scale pattern. You get a huge upper level high pressure system, an upper level ridge into Greenland with a negative NAO, and you get a deep trough in the eastern U.S. And this is generally favorable for storm development along the East Coast. You get these nor'easters, these areas of low pressure to develop up the East Coast and move up. The high pressure off over Greenland, that blocking high, generally will not allow these low pressure systems to readily escape and go out into the Atlantic. So you get deeper systems. We got better dynamics for deeper, stronger storm systems in general with a negative NAO, or North Atlantic Oscillation. Positive NAO is going to be different. We're favored for more mild conditions with a positive NAO. Okay. Generally, what we want for PNA stands for Pacific North American pattern. Generally, it's a positive PNA when you have a ridge in the west and warmer than normal temperatures, and a trough and colder than normal temperatures in the east. That's a positive PNA. A negative PNA is usually the opposite, where you get the trough in the western United States and a warmer ridge in the eastern United States. Okay, so these are all things I take into account. Now, teleconnections again play a significant role. Here's the Madden-Julian oscillation. See this? These diagrams here on the left. This is December, January, and February, the typical temperatures you get. Now, the warmer temperatures are indicated, above normal temperatures are indicated in the oranges, yellows, and kind of like reddish hue, while the colder temperatures or below normal temperatures are indicated in the bluer shadings on the diagram. Now, I want to point out there's certain favorable Madden-Julian oscillation phases for colder than normal weather, and those are phase 8, phase 1, and phase 2. So constantly we're paying attention to the Madden-Julian oscillation phases during the wintertime. We're paying attention to the Arctic oscillation, which I just spoke about, the North Atlantic oscillation, and the Pacific North American pattern. And then we're also paying really good attention to something known as stratospheric warming, and I'll get to that here in a minute. But generally, this is a breakdown on the right in the text showing you, there's something known as constructive interference and constructive, or actually destructive interference. So constructive interference occurs when you have multiple teleconnections aligning themselves, further enhancing a certain pattern. Whereas destructive interference is, let's say you have a negative NAO, which favors a trough on the East Coast, but then you might have a Madden-Julian oscillation phase, let's say phase 5 or 6, with warmer than normal temperatures across the East. So their destructive interference is one teleconnection offsets the effects of the other. Okay. So in summary, when the NAO and the AO are negative, along with a positive PNA pattern, and an MJO phases 8 through 2, from December through February, the winter months, we can expect colder than normal temperatures and above normal precipitation impacting the eastern U.S. When the NAO and the AO are positive, along with a negative PNA pattern and an MJO phases 3 through 7, this is warmer than normal temperatures and below normal precip, so warmer and drier than normal for the eastern U.S. Occasionally, the teleconnections counteract each other, resulting in near average temperatures. At other times, these teleconnections outweigh each other, favoring a more specific weather regime. Okay, it could be warmer, drier, or colder weather than normal. Right? So that's the real trick in seasonal forecasting, is to figure out what's happening with the teleconnection phases and being able to accurately forecast them and producing your seasonal forecasts. All right, this is a diagram. I know it may be difficult for you to see, but this shows you El Nino winter snowfall patterns. This is generally across, and I picked a lot of cities across the U.S. here, not just Southeast Virginia, but just to let you know, locations, in summary, locations with above average precipitation during El Nino winters extended from California to the mid-Atlantic states with a more active southern storm track, which I kind of explained that in the diagram in El Nino, a more active subtropical jet stream. Notice that other teleconnections such as NAO, negative or positive phases come into play during El Nino winters. So you can't just simply look at El Nino and say, it's El Nino winter, this is definitely going to happen. Again, I reemphasize the fact that the other teleconnections, Madden-Julian oscillations in the Pacific, the North Atlantic oscillation, the Arctic oscillation, there's just so many things, stratospheric warming events, that can come into play and trump El Nino. All right? So it's a matter of determining which teleconnection is going to be more dominant over the upcoming winter. Also looking at the snow cover that Judah Cohen has done that research on over Siberia. All right? Here is just a teleconnection history. I took a sample size from the Climate Prediction Center. These are their charts here. And the circle areas on the diagram here show below normal or negative patterns. Negative NAO on the left, and then on the right, far right-hand side, I have negative AO. This is what happened in the late winter, early spring this year across the eastern U.S., especially in the Southeast Virginia. This favored a deep trough of lower pressure in the upper levels to form over the eastern U.S., a ridge of higher pressure to form over the western U.S. So we had much below normal cold that really lasted from late winter into a good portion of the early spring this past year in 2018. And that's going to happen. You know, we had a strongly negative NAO, strongly negative AO. They coincided at the same time, and along with a sudden stratospheric warming event. All right, and so it took a while for the temperatures to actually warm up across Southeast Virginia and the Mid-Atlantic as a whole in the spring of 2018. And that was because of these teleconnections. This is the example of constructive interference where both the NAO and the AO were both negative, and then the MJO phases were also in favor of colder than normal weather in the east. And then you had a sudden stratospheric warming event, all at the same time. Everything lined up, and I will emphasize this, it honestly is really all about timing of all these teleconnections. Now, sudden stratospheric warming events, this is an example of one that occurred back in March of 2015. What happens with sudden stratospheric warming events is temperatures in the stratosphere, which is that second layer in the atmosphere. Stratosphere is typically, we live in the troposphere. That's where all our weather occurs. But above that troposphere layer is something known as a stratosphere. And when temperatures really rapidly increase, research has shown this, temperatures rapidly increase in the stratosphere on the order of 50 or even 90 degrees in just a few days. This typically leads to the displacement of Arctic air from higher latitudes into the middle latitudes. And it also results in more blocking at higher latitudes where you get a strong upper level high or a ridge. And if that happens, it dislodges a lot of cold air it sets up a Arctic connection, a cross-polar flow from the Arctic all the way into the mid-latitudes. So in this case, when you have stratospheric warming events where the stratosphere's temperatures are just really rising quickly over short periods of time, you generally get a displacement of Arctic air into the lower 48, the United States as a whole. All right, and typically you have below normal temperatures along with big winter storm events during stratospheric warming events like this. Right, and you can Google this at home, and you can really do some research into it yourself. I've looked into this, and it's a real interesting topic to look at, but it's definitely something you have to figure in the winter forecast. Now, there are events, sometimes sudden stratospheric warming events don't happen till later in the winter or even early spring. Other times they happen right in the heart of winter. So it's really, you got to pay attention when you're talking about winter forecast and seasonal forecasting as a whole. You definitely need to pay attention from the surface all the way up to 60, 70,000 feet in the atmosphere. It all is connected. And then sea surface temperature anomalies, we definitely have to look at these. Again, I just want to mention the emphasis on this, okay? You need to be paying attention to things, all right, when it comes to water temperatures in these oceans. These oceans are huge heat reservoirs, and they're responsible for helping to create, there's areas of above normal sea surface temperatures, there's below normal sea surface temperatures. Where these set up is so critical to how the long wave pattern, the troughs and ridges, is going to set up. So long wave troughs in general, they seek colder than normal surfaces, while long wave ridges seek warmer than normal surfaces. This greatly impacts the jet stream configuration, that pattern across the entire northern hemisphere. And we got to pay attention all the way out to Asia and Siberia, all the way to the US. Because guess what? Everything moves west to east, like I mentioned. The blue H on this diagram here, I'm showing you where upper level ridges are favored because of colder than normal temperature, the temperatures, right? And that's actually wrong, and I apologize for that. The blue H should actually correlate to the above normal temperatures in the wintertime, okay? So we had an example of the warm blob back in a few winters ago off the west coast, where the sea surface temperatures were well above normal in the Gulf of Alaska. Long wave ridges generally tend to seek out those warmer than normal surfaces, like I have indicated. All right, so just keep that in mind, that warmer or colder than normal sea surface temperatures have a huge impact on our global weather patterns. All right, so taking all that into account here at Spot On Weather, here is the official winter forecast, okay? We're expecting an upper level ridge to predominantly influence the weather across the western United States, while an upper level trough will influence the weather across the eastern United States. And then we have El Niño conditions developing this winter, which kind of complicates things a little bit in the forecast. It all depends on the strength of El Niño too, and I didn't even mention that, but if you have a weak El Niño, it could mean a difference between colder and snowier than normal versus a moderate to strong El Niño where it might be warmer and drier than normal. So the strength of the El Niño is also important. Right now, as I mentioned, we're expecting a higher end weak El Niño, temperature anomalies of 0.5 to 1 degree Celsius in the equatorial eastern Pacific waters. But it could easily go up a little bit stronger than that and get into that moderate category of El Niño. So it's something to keep an eye on. But we do expect an upper level ridge to predominantly influence the weather across the western U.S. So that's going to be warmer and drier across the western U.S., while an upper level trough will influence the weather across the eastern United States. Okay. We expect that El Niño, along with the North Atlantic Oscillation, is going to be the primary driving mechanisms behind the sensible weather, what we actually see this upcoming winter here in Southeast Virginia. The NAO will occasionally amplify the impacts of El Niño, resulting in numerous episodes of high latitude blocking. Remember, if we have a negative North Atlantic Oscillation, it generally tends to lead to a blocking over Greenland, and that generally tends to keep a trough pattern locked in the eastern U.S. and a huge ridge over the central Atlantic. Conditions will likely be very wet. We're expecting for Southeast Virginia, I'll just cut to the chase here. For Southeast Virginia, we're expecting a colder and snowier winter this winter. The reason is all those factors I just looked at. We're expecting the teleconnections to align more favorably for a colder than normal winter. We're expecting a long wave trough to set up for the most part throughout the winter over the eastern U.S., which is going to favor the development of nor'easters, the development of coastal low pressure systems, along with those those colder outbreaks. Now, we're not going to have it. We're expecting a departure of 1 to 3 degrees Fahrenheit below normal. We're also looking at a snowfall 3 to 5 inches above normal. Okay, but just like the last couple of years with the snowfall, I want to mention that one big snowstorm can really, really impact the average. Let's just say. For example, last year, the average snowfall in the Hampton Roads areas is usually about 7 inches each winter. Well, the early January snowstorm, we got 10 inches to 13 inches of snow in the area. So with just one major winter event, that pretty much gave us above normal seasonal snowfall last year. So just keep that in mind. But we are expecting a 1 to 3 degree below normal temperature departure for the winter. And when I talk about winter, I'm talking about December through February. 1 December through the end of February, 28 February. We are expecting above normal snowfall, 3 to 5 inches above normal. So we'd expect 10 inches, 10 to 12 inches for the winter. We do expect these teleconnections. NAO, again, will occasionally amplify the impacts of El Nino. And then overall across the United States as a whole, I kind of show you this here in this video as well here to end it. How I expect the upper level ridge to set up over the Pacific Northwest, and that's going to dislodge colder air into the eastern U.S. And I will say this too, that it won't stay locked in all winter. So yes, I'm expecting a colder and snowier winter than normal for Southeast Virginia, but that is going to change with time. So it won't remain locked in place with a trough in the east and the ridge in the west. There will be some temporary fluctuations to that overall long wave pattern and where the jet stream sets up. But overall, that's what we're looking at. We looked at everything, all these factors taken into account to come up with the 2018-19 winter forecast. So get ready, Southeast Virginia. It's looking like a colder and snowier winter this year. So I hope everybody's ready. I hope you enjoyed this presentation. That concludes it. We're spot on weather. Hopefully everybody's staying safe during Hurricane Florence. Looks like it's moving away from the Hampton Road cities. So it looks like we did really well with this storm, which is good news. But that wraps up this winter forecast for spot on weather. Remember, if we're not spot on, we're not doing it right. I wish everybody a great, great weekend. Take care, everybody.